Okay, the first question is, what is the local linearization of g of x equals e to the x cubed? I'm using x cubed. Your question might say x to the fourth or fifth or something like that. Near x equals 1, no approximations. So recall that we're trying to find, if we're trying to find the local linearization, that's the same as the tangent line approximation. So I've got my ordered pair, so I need g of 1, and g of 1 is e to the 1 cubed, which is e to the first, which is e. And so my ordered pair is 1 comma e. I need my slope. My slope is always going to be g prime, so I'll find an equation for g prime. Well, this is e to the x cubed, and so we've got e to the x cubed times the derivative of x cubed, 3x squared. And so g prime of 1 is e to the 1 cubed times 3 times 1 squared, which is, that's going to be 3e. So there's our slope. So put it together, and we have our local linearization is y minus y1, so y minus e is equal to m, that's 3e, times the quantity x minus x1, which is 1. You could write this as y is equal to, you could also write this as y is equal to 3e times the quantity x minus 1 plus e, or clean it up, distribute, we get y is equal to 3ex minus 3e plus e, which again, one more step cleaning is 3ex minus 2e. So there's your local linearization. That's the same as a tangent line approximation. And so ultimately what we are saying is that the function g of x, which is e to the x cubed, can be approximated by 3ex minus 2e when x is near 1. And if you graph those two functions on the graphing calculator, for example, make this y1 and make this y2, and look at where x is near 1, you'll see that these two lines are very, very close to each other around x equals 1. It won't be true at other x values necessarily, but when x is equal to 1, they'll be very close to each other. For the next problem, you're asked to find the tangent line approximation to the cosine of x at x equals pi over 4. Do not approximate. So again, tangent line approximation is the same as local linearization. So we're going to find that line. So I need an ordered pair. I've got, I need an xy ordered pair. And so that x value is given to be pi over 4. And the y value is the cosine of pi over 4. We know that the cosine of pi over 4 is root 2 over 2. So there's your ordered pair. And if y is equal to the cosine of x, then y prime is equal to the opposite of the sine of x. And so y prime at pi over 4 is the opposite of the sine of pi over 4, which is the opposite of root 2 over 2. So there's our slope. So we put this together, and our tangent line approximation is y minus root 2 over 2, again, we're not approximating, is equal to m, negative root 2 over 2, times the quantity x minus pi over 4. You could also say y is equal to the opposite of root 2 over 2 times the quantity x minus pi over 4 plus root 2 over 2. And so there's your tangent line approximation. Of course, you could distribute your negative root 2 over 2 and clean it up, but this is absolutely fine when working with these exact values. Now, to 1 decimal, estimate the error's maximum value on the interval 0 to pi over 2. So I'm going to pause it for a moment, but the next thing that you should do is graph these two functions. So again, graph this maybe as y1, there's the cosine of x. Graph this as y2, And we know, as I mentioned in the previous example, we know that the cosine of x will be very close to, it's approximately equal to this line when near, so this line here, when near pi over 4. Graph it from 0 to pi over 2. Keep in mind that pi over 4 falls exactly halfway in that interval, at the midpoint of that interval, and you'll see what I'm talking about. I'm going to pause it for a moment. Okay, so when I graph this on the interval from 0 to pi over 2, which is what we're told to do, 0 to pi over 2, there's pi over 2, there's 0. My function cosine, we know, starts up high at 1. Here's pi over 4. Here's pi over 2. And the graph does this. And you know what the cosine function looks like. It does this on that interval. Okay. Now at pi over 4, specifically, the two functions must be equal to each other. We know they're going to be equal to each other. But here comes my linear function. So this is the other function. So our linear function, which was y2, looks like this on this interval. Looks like this. And again, keep in mind the whole goal was to find a function which approximates well our function around pi over 4. We can see that the blue line and the red line are very, very close to each other around pi over 4. The maximum error, which is this vertical distance, occurs either at 0 or at pi over 2. And this question, part C, number 12, part C, was about where does the maximum error occur. So we know it's either here, this is option A, or it occurs here, option B. We can see that because the vertical distance is greatest at those 2 points. So at this point, you want to go to your table. You were given the option of estimating. Go to your table and look at, okay, at x values of 0 and pi over 2. And in y1, you'll get the y values for the cosine, and in y2, you will get the y values for your tangent line approximation, and then find the difference between those two values. I'm going to let you finish this problem on your own, but find the difference between those two values, and whichever distance is greatest, again, you're thinking absolute value, that's where the error is maximized. Now, you were asked to round the difference between those two values, I believe, to 1 decimal point. If you have other questions on that, I'd be more than happy to talk about it more tomorrow in class.